2. They both work? Okay. Okay. Cool. Nice. Oh, perfect. Hi, everybody. My name is Forrest. I'm one of the founders of Rubicon. We're an order book protocol for Ethereum built on layer 2 networks. Today we're live on Optimism, but soon we'll be on a few more networks. Today I'm going to talk a little bit about differences between layer 1 blockchains and layer 2 chains and how those impact our design decisions when we're building decentralized exchanges or really any DeFi app on these layer 2 networks. So if you're a developer looking to make the jump, I'll have some insights for you here. So quickly, we're going to review Ethereum mainnet from the perspective of a DeFi app. It's incredibly expensive. I don't have to say this twice in this room. Either a trading firm or Justin Bieber or someone out there is willing to pay more for Ethereum block space than you are. So this makes things really difficult for any DeFi app that requires any type of active management or position management. Next, it's incredibly slow. So we measure blockchain performance and speed across 2 primary metrics. These are throughput and latency. Throughput, how many transactions can the system handle, measured in TPS, and latency, how fast does it take for a transaction to process. A helpful kind of way to view this is as a highway. Throughput, how many lanes are there, latency, how fast are the cars traveling. And lastly, on mainnet, we have pervasive MEV. So I realize I'm blocking this a bit, but maximal extractable value is a feature, if not a total threat to any smart contract platform that exists out there. To date, we know of $600 million of value extracted on Ethereum, which means the real number is probably more. This is an incredibly hostile environment to go try and build a financial system. It's expensive, it's slow, and your inputs and outputs can change randomly when you broadcast a transaction. So what type of decentralized exchanges rose out of this very trying, extreme environment? Automated market makers. I would have to guess that most of the people in the room have used AMMs before. Just as a very quick review, these are passive liquidity pools that charge you a fee as a trader and rely on arbitrageurs and other like more active traders to keep the pools in line and prices in line with real market prices. Importantly, they optimize for the minimum amount of transactions required to keep markets functioning and operational. So very few transactions have to go into an AMM in order for those prices to stay in line with external venues. But the Rollup-centric roadmap is upon us. Ethereum is all in on Rollups as the primary scaling solution for its blockchain. This means we will be moving activity off of the Ethereum main chain onto these Rollup networks. Just for quick review, Rollups at a high level, we move transaction execution and storage off-chain, where an operator batches transactions together and posts that transaction data back to layer 1. We have systems of proofs in place to determine whether or not the transaction data is valid that this operator does. With Rollups, we talk about an honest minority or a can't be evil assumption that these proofs enforce. So I think there's a very healthy debate going on now of how much activity will stay on mainnet. It's very expensive, it's very slow, and L2s are here in a very young state. You can use them today. They're cheaper and much faster than mainnet. There are a lot of cool apps there. Maybe I'm a little biased. But still, mainnet's king. There's no second place there. And I think a lot of people are kind of on the fence on why has there not been this adoption, but the reality is, however you look at it, mainnet's only going to get more expensive with increased demand for Ethereum block space. Users and apps will be forced to move to layer 2s, however slowly they may take. So next, I want to cover a really important idea when you're talking about rollups, which is they can surpass the performance of the Ethereum base chain. So in case you missed it, last week Optimism, a very popular layer 2 network, launched their governance token. And at the peak of their congestion on their network, they were actually handling more transactions per second than Ethereum mainnet. This is something that even 2 years ago people would have been pretty skeptical of. But I think this is incredibly exciting. And yes, this is totally cherry picking a stat from a time of high congestion, but it's a glimpse at what I think will be really the future of Ethereum, which is mainnet chugging along towards the bottom of the table, and multiple different rollups surpassing it in its capacity, batching those transactions back to mainnet. So next, I have a very important message if you're a developer who wants to build an app on L2, and that is key differences. And the most notable one is L2 gas does not equal L1 gas. This is a common misconception. We talk about EVM compatibility. Your code does not have to change to go onto a lot of rollup networks, but things work differently. So this is ripped straight from the Optimism docs, but really it applies to any layer 2 network. Any rollup is going to charge you as a user a slight premium on the cost it takes them to batch your transaction data back and post it on L1. So we have this L2 execution fee and the L1 data fee that make up your cost for as a user on Optimism. We're going to ignore the L2 execution fee. It's kind of boring. It's just a congestion fee. And 90% or more of your gas cost comes from the L1 data fee. So the cost required to post it back to L1, what are they doing? They're applying an overhead. They're applying a fixed overhead based on your transaction size, essentially, as well as a dynamic overhead to ensure their own profitability. In the past, this dynamic overhead was a 1.5x multiplier. Now it's a 1.24x, and we can expect this number to get more and more accurate with time as these rollup networks progress. So gas works completely differently, and really what I'm getting at here is there are different optimizations for L2 specifically that don't work on L1. So your assumptions as an L1 developer may carry you in the wrong way and lead you astray. I want to give some credit here to Aave real quick, who in January made a really, really cool change where they specifically just changed the way that their contracts were passing data back and forth on their L2 deployments on Optimism and Arbitrum, and this brought at least like over 4x gas savings to their users. So this is an L2 specific optimization in their code. It only required 3 contracts being slightly changed around, and it makes Aave v3 more performant on rollups than it is on alternative layer ones, which I think is somewhat impressive. So good shout out to them. You're only going to see more of these code optimizations. This does not work on L1. This would actually ruin your protocol if you did this on L1, importantly. So it's an L2 specific optimization. But L2s are not lazy forks of the EVM. We think EVM compatibility, my code works out of the box. This is just another copy of mainnet. They're not forks, all right? We have plenty of side chains to do that at this point, to be lazy forks. L2s are specialized execution layers who compete with each other. What do they compete on? Like we mentioned earlier, Ethereum's weaknesses. They're going to compete on costs. There's a great site out there called l2fees.info. You can view all of the rollup fees next to each other in a quick little table and see who's winning at the moment. They're going to compete on performance. They're going to compete on capacity and latency. You can already see this today. If you've used a rollup, you know how quick they may be compared to mainnet or even other chains. And lastly, they're going to compete very soon on MEV and their approach to block production. This is a developing space. There's a lot of new thought here. If you have not heard of the MEV day or any of these presentations, this is going to have a lot of implications for how dApps on L2 function and work. It's really going to change the game in terms of how the blockchain works if most of our usage moves to these separate networks. So ultimately, all these rollups are competing over at the end of the day is Ethereum block space. So this is kind of what things look like today. You have Optimism and Arbitrum vying for who can get more usage and who can post more transactions back to L1. But we're still so early in this movement. I think I checked this morning. Only 1.2% of Ethereum gas in the last 24 hours was used by rollups as an aggregate, not just these two. So I think if we really listen to the rollup-centric roadmap, we're talking well over 50% of mainnet gas is rollups posting data back. And I think it's a conservative estimate to think that by the end of the year, 10% of mainnet gas per day could be used for rollups. So they're fighting over block space and users at the end of the day. We have specialized execution layers, which I think is really exciting. So I've kind of assumed this whole talk that rollups are only getting better and better and cheaper. How do we actually get here? We talked about code optimizations of things you can do as a developer to make your app more performant on L2, but luckily there are protocol level changes that will help you out as well. Perhaps the most important, EIP 4844. This is also known as proto-dank sharding, which is a fun name. And we actually had a Ethereum core developer here in March explain this concept and the evolution of the idea to us. It's very interesting. Essentially, all it does is add a new transaction type onto the consensus layer. So think ETH2, and it allows Rollups to post way more data to L1, and it's much, much cheaper. So it's a 100x for their capacity. Hopefully, fingers crossed, Ethereum core development, it could be this year, which could be 3 years. Next, we have the adoption of BLS signatures. This is signature aggregation people have been really excited about, like basically back to the beginning of Ethereum. And really, rollups are ready for it. So all it takes is wallets to start figuring out how to give their users the ability to use BLS signatures. And it's hard to get benchmarks for this, but it would be orders of magnitude. You're getting multiple signatures condensed down to a single signature. You're having to batch back to L1. Kind of a form of compression at the end of the day. And lastly, we have something happening today, which is actual compression. So how do you make data smaller for users' transactions on L2? You compress the batches you have to post back to L1. Optimism's been compressing their batches since March through a known compression algorithm and library, and I think Arbitrum has plans to do the exact same thing in their upcoming Nitro upgrade. At Rubicon, we saw roughly a 30% reduction in transaction costs when Optimism started compressing transactions, which is pretty significant. So they're only going to get better and better, and there is a full roadmap for both of those teams to use different libraries and different algorithms to improve compression as well. So all of this to say, we're not on mainnet anymore at all. These are completely separate, dedicated, specialized execution environments. They are not just mainnet forks. They function differently. Whereas before, you may have had to optimize for a minimum number of transactions for functioning markets. Now, we're actually a little more concerned with data, but there are so many cool protocol level changes that compute's getting very free. So I think this is incredibly exciting. And what we've decided to do is we believe that these execution layers will need a core order book protocol. This is impossible on mainnet, but thanks to the progress of these layer 2 scaling solutions, we're able to do this today in production. So we also believe that this should be a fully lit market and fully on-chain. We don't think that core trading and exchange logic should be in some off-chain request for quote system or an off-chain order book. Kind of seems like a centralized exchange with extra steps, right? So lastly, we think in the spirit of DeFi, it should be a system where you enable equal access for all players to liquidity providing. Passive retail providers should be able to participate and get yield just as much as active managers. So we've kind of built a cool liquidity mechanism where anyone can deposit and get market making yield. So great, a screenshot of a block explorer. I'm sure everyone knows what's going on. Just kidding, we're gonna dissect it. So this is a market making transaction on Rubicon. Essentially, what you're able to do, market makers on an order book, right? They're canceling most of their transactions. Price changes somewhere else. I have to cancel an outstanding order, and I have to place a new quote with an updated price. On Rubicon, we're actually able to batch this all into one single transaction on chain. So this is a market maker managing their entire outstanding book on WETH USDT, a pair on our order books, and they're canceling 10 outstanding orders and requoting new orders all in a single transaction. You can't see it here. It's like $1.25 gas fees for requoting 10 orders outstanding on the order book and reflecting off-chain prices. We think this is pretty exciting, and kind of like I outlined during this talk, compute's only getting cheaper and cheaper. So you can imagine these wars of block-to-block requoting, where market makers for relatively cheap are able to completely adjust to external venues and off-chain prices every single block or every couple of blocks. This is compared to Uniswap v3, which was designed for the Ethereum base layer. You have this kind of constraint of you only want to optimize for a small amount of transactions. So here's a Uniswap v3 position adjustment from the same L1 batch as ours, roughly the same conditions on Optimism and mainnet, which was 84 cents. So for a marginal reduction in fees, you're getting way less functionality than a limit order book on-chain, which we think is a little less exciting, and you just don't have the customizability of the limit order book. So you can either requote block to block and do high-frequency trading in DeFi, or you can mint and burn Uniswap v3 NFTs on a longer time horizon. So we're live today on Optimism. We have 7 markets at app.rubicon.finance. You can check us out. Here's our OP USDC books. And we want to invite more market makers to use our liquidity pools later this year. You can send a note to mmt@rubicon.finance if that's something like block-to-block requoting and high-frequency trading in DeFi is up your alley. You can follow us on Twitter @RubiconDeFi to keep up with our latest updates. And maybe like everyone else here, we're hiring engineers. And if you like to work with smart contracts or build trading systems, reach out. Thanks.